Thank you for watching this project help video for lesson 14. I will help you answer each question in the project by providing step-by-step instructions using example problems. A good strategy might be to pause the video after each example and then work the corresponding problem in the project. All right, so the inequality that compares the number of projects graded in Algebra 1b to the number of projects graded for Algebra 1a is y is greater than 3x. Graph the inequality. Make sure to discuss the borderline style where the shading is and the y-intercept. So this lesson is obviously about graphing inequalities. And graphing an inequality is exactly the same as graphing an equation with an equal sign in it, the equation of a line, with two differences. One is this borderline style, being either dashed or solid. And the other one is that we have shading. We have to decide where to shade, either above or below. So to give you a real quick crash course, all right, when we have a greater than or a less than symbol with no or equal, all right, that's when we get a dashed borderline. Right, if it has the or equal, if it has the line underneath it, that's when the line is solid. So that's how I kind of remember it. If the line is underneath the inequality, then that's when we get a solid line. All right, and having something that's greater than or equal to or less than or equal to does kind of indicate to include that as part of the solution because of the or equal. It's analogous to the closed circle when we're graphing inequalities in one variable. Whereas in this case, we have just y is greater than 3x. And the greater than or the less than symbol, remember if it was an inequality in one variable, that would be indicated with an open circle when we graphed it. And in this case, since we're dealing with lines, right, in the XY plane, that's when we get a borderline that's dashed. All right, so the inequality symbol also indicates where the shading is. So this inequality symbol is doing quite a bit when we have the equation of an inequality in two variables. It's telling us two things. It's telling us the borderline style and where the shading is. Greater than or equal to means shaded above, whereas less than or equal to would indicate shaded below. Kind of makes sense. Greater, above, less, below. And then we can also graph the y-intercept because this is still y equals mx plus b. In this case, there is no b, right? So we get that the y-intercept is, in this case, 0. So I could crudely go ahead and make a graph for you, and then maybe I'll go ahead and do it in Desmos. Right, so just to check your answers, you guys can go to www.desmos.com as well and graph inequalities the same way you graph lines. And take a look at the inequality and see what's there. So in this case, if I graph this inequality, right, I would have a y-intercept of 0 because I can rewrite this inequality as y is greater than 3x plus 0. And it's this constant out here that's our y-intercept, which means right at the origin in this case. So we have a point right there. All right, then we're going to go ahead and graph it just like we would any other line. So here's the slope, right? It's the coefficient of x here. It's 3. I'm going to write it as the fraction 3 over 1, which would mean to get from one point to the next, I need to go up 3 and to the right 1. So here's 1, 2, 3, to the right 1, and I would get another point. All right, so I could keep doing that, but really 2 points is all I need to graph the equation of a line. In this case, because we have a greater than, a strict inequality, we get a border line that's dashed. So I'm going to go ahead and do the best I can here on the screen, drawing my dashed line with the slope of 3. It goes on forever. Now we have to decide where to shade. And in this case, remember I said that greater than means shaded above. Greater, above. Makes sense. Above what? Well, take a look where the y-intercept is. So a inequality symbol of greater than, meaning shade above, means shade above that y-intercept. So that would indicate all the points up here, above that point. And we would shade it like that with a dashed line. And that would be how we would graph this inequality. The inequality that represents the sum of the number of watched project videos in Algebra 1A and 1B is 8x plus 12y is greater than or equal to 48. All right, so that was from the last part of the project. This inequality is in standard form. It's in standard form because we got the variables, the x and y, together here on one side. Rearrange it so that it is in slope-intercept form. The reason why they want you to do this is because when we graph an inequality, we need to have it in slope-intercept form, not standard form. All right, so what that means is we got to get the y all by itself. All right, so it's like solving for any other variable where we're going to use our inverse operations to isolate, in this case, the y, because we want it to be in the form y greater than or equal to mx plus b. Instead of an equal sign, in our case, we're going to have one of the inequality symbols. All right, so I want to isolate the term with the y in it. That means this 12y. I'm trying to isolate, get that by itself on the left-hand side here. So I got to get rid of this x term. All right, so I'm going to subtract 8x from both sides of this inequality. All right, so then I get that 12y is greater than or equal to, and I know that I wrote this 8x underneath the 48 here. Maybe I shouldn't have, because these two things are not like terms, right? They can't combine. We can't combine an x term with a number, so I just have to write out minus 8x plus 48. All right, now y is almost by itself, except for it's being multiplied by 12. So we're going to undo multiplying by 12 by dividing by 12. And we go ahead and we have to divide every term in this inequality by 12 then. All right, so that cancels out here. And we get that y is greater than or equal to, notice it's still greater than or equal to. I didn't divide by a negative. I divided by a positive, so I don't switch it. In this case, I would have minus 8 twelfths x. Usually you see this x not written in the numerator, but written out on the side. It's really the same thing. And then here, 48 divided by 12 is 4. I could go ahead and simplify this a little further by just reducing that fraction here. And in this case, I can divide the numerator and the denominator by the number 4. So when I do that, I would get negative 2/3 x plus 4. All right, so I just changed what we had originally in standard form into slope-intercept form. Finally, we want to graph the inequality in the last question. And here's our inequality in the last question. So I put it here just to remind us what it was. And I think the question actually asked you to explain how you would graph it. Well, the first step was obviously to get it into slope-intercept form like it is now, the inequality. Then we're going to graph it just like we did in question 1. So if I were graphing this, I'm going to make a crude graph here on the screen. I think you might be asked to identify the graph that goes with the equation. All right, but either way is what we do is we go to the y-intercept, and I'm going to plot the y-intercept. In this case, it's at 4. 1, 2, 3, 4, and I'm going to put a dot. All right, so that was step 1. Graph the y-intercept, that constant term at the end on the y-axis. Then we're going to use our slope to get another point. So I kind of think of this one this time as this, negative 2 over 3. Remember, this is the rise in the numerator over the run. So it means to get from one point to another, since this is a negative on the rise, it means I should go down 2. And this is a positive on the run, so it means go to the right 3. So to graph this one, I would start at from one point and go down 2 and to the right 3 and put another point. All right, now I have to decide, should my border line be a solid line or a dashed line? And then where the shading should be. And that is solely determined by the inequality symbol itself. Right? It has nothing to do with it, the slope being negative or positive. Only the inequality symbol determines the border line style and where the shading is. Right, so notice we have the or equal. That's kind of my clue that that's a solid line then right there. If you forget or you need a way to remember it, well, the ones that have the line underneath, the inequalities are a solid line. All right, so I kind of draw it out the best I can there, draw that out. And now that symbol there is greater than. All right, so greater than means shaded above. So I go to the y-intercept, and I know that every point above that should be shaded. So that means this side of the line. And then we're done. So now question 4, you're going to put question 3, what we just did, how we just graphed that inequality, into words. Basically explain how to graph an inequality that is in standard form. And then here I said go ahead and use this inequality, 2x minus y is greater than 10, as an example to help illustrate your point. And you need to tell me that step 1 would be to get it into standard form. So tell me that first you have to get the inequality into standard form. Sorry, excuse me, get it into slope-intercept form, right? We cannot graph it unless it is in slope-intercept form. So get the inequality from standard form into slope-intercept form. And of course, when you're writing this in your projects, you should use complete sentences, right? So get the inequality into slope-intercept form. So get it into slope-intercept form. I'm going to go ahead and abbreviate this here. All right, so in this case, if I were doing that with this problem, I would need to subtract the 2x from both sides. Then I would have that minus y is greater than negative 2x plus 10. Notice after you get used to doing these and manipulating these equations and inequalities, after a while they get really easy. You can think of just picking up that term and changing its sign and throwing it to the other side. And then I don't want a negative y, I want positive y. So I need to divide everything by negative 1. That just changes the sign on everything and also flips the direction of the inequality. So in the example I have here, I would explain that first we have to get it into slope-intercept form, and this is what the slope-intercept form is. Then I would go about explaining what we just did in the last question. That first plot the y-intercept. And I'm going to use b. Remember, b is used to indicate the y-intercept. So you would tell me, if we're using this example, you would plot a point at negative 10 on the y-intercept, because the point 0, negative 10 is the y-intercept. Then you would use the slope to plot another point. So use the slope, or rise over run, to plot another point, or a second point. Then the last step is use the inequality to determine the borderline style and the shading. So we're using the inequality symbol to determine the borderline style, dashed or solid, right? In this case, dashed, right? That's dashed. So you would tell me that because it's a strict inequality, I would have a dashed line, and the shading would be below. So I'm going to write shaded below. So dashed borderline, shaded, in this case, below. And then that would be it. After you shaded it, then you would be done. So just go ahead and generally explain these steps.